This is the Masterclass video for the topic of static electricity. The diagram shows the direction of electric field lines around an isolated point charge Q. We can see that the direction of the electric field lines is pointing away from charge Q. Away from plus into minus, the direction of electric field lines should be pointing away from positive charges into negative charges. Therefore, Q should be positively charged. With Q being positively charged, we can see from the figure that there's a force acting towards Q. Therefore, R is attracted towards Q. The law of electrostatics states that like charges repel and like charges attract. Since R is attracted to Q, R should be negatively charged. Therefore, the answer is C. Explain what is meant by an electric field. An electric field is a region in which an electric charge experiences an electric force of attraction or repulsion. A piece of metal foil is attached to a metal rod as shown in figure 9.1. Both the metal rod and foil contain negative charges or electrons that are free to move throughout the metal, while positive charges are not free to move. Both the rod and the foil have no overall charge. Take note that no overall charge means that the number of positive and negative charges is the same, not that there are no charges. Rather, there is no overall or net charge. A negatively charged plastic strip is held close to the top of the metal rod. It is then observed that the metal foil moves away from the metal rod. Explain why. Recall the law of electrostatics. Like charges repel and like charges attract. When the negatively charged plastic strip is held close to the top of the metal rod, the negative charges are repelled to the lower bottom end of the metal rod and foil as like charges repel. As the two ends of the metal rod and foil have like charges, they repel each other. Therefore, the metal foil moves away from the rod. A large thundercloud becomes charged with a negative charge at its base as shown in figure 6.1. Tall buildings are fitted with thick strips of copper called lightning conductors as shown in figure 6.2. The copper strips contain negatively charged particles that are free to move within the copper strip itself. The lightning conductor is also attached to a large metal plate in the ground. Describe and explain what happens to the negatively charged particles in the copper when a thundercloud passes overhead. We recall the law of electrostatics. Like charges repel and like charges attract. When a thundercloud passes overhead, the negative charges at the base of the thundercloud repel the negative charges in the copper strip towards the bottom end. And the negatively charged particles are subsequently discharged through the metal plate connected to the ground.